All right, here we go. We are solving exponential equations using logs this time. So I just put this first problem here to remind you how we did exponential equations before. So like 25 is a power of 5, so I would change 25 to 5 squared and leave 3x minus 1. 125 is 5 to the third, so change that to 5 to the third and then 5x. So in this problem, I was able, 5 and 2 times 3x minus 1 is 6x minus 2. And 5 to the 25x. I was able to get the bases to match. So once the bases match, I basically know this. I know that this exponent has to equal that exponent, so there's my equation to solve. 6x minus 2 has to equal 25x. So 19x, so x equals negative 2 over 19. Okay? But in all the rest of these problems, I'm not going to be able to do that like little trick there. For instance, in letter B, 7 and 12, they're not powers of anything, and they're definitely not powers of each other. So there's two ways you can approach this. You can do one thing where you write this in log form. If I write this in log form, I would write log base 7 of 12 equals 3x. Because remember, it has to say this, 7 to the 3x equals 12, and that's what that says. I go to my calculator, log base 7 of 12. So press the math button, go down, go to log base. So log base 7 of 12, get that answer, and divide it by, oh my gosh, divide it by 3. And there we have it, 0.4257. That's one way to do it. But if you can't use a well, sometimes, people don't want you to do it this way. There's another way to do it, and that is to take the log of both sides. Now, take the log of both sides. So I would write log 7 to the 3x equals log 12. So once I can do a log, or you can do something later on called the natural log. But either way, now that I have the word log here, I've just taken the log of both sides. This 3x is now allowed to come to the front. So I can write this as 3x log 7 equals log 12. So if I want to solve for x, I want to get rid of the 3 and the log 7. 3 log 7. So now I have x equals whatever this is, because these are all canceling, right? So log 12 over 3 log 7. Uh-oh, commercial. So log 12 over 3 log 7. And look at that. Same exact answer as before. So depending on, it doesn't really matter which way you do it, I guess, depending on the situation. All right, so this next one, I have to get this part alone before I can do my fancy work here. So I got to add 6, that makes 24, then divide by 4, that makes 6. So 2 to the 5x equals 6. Okay, and from there you kind of make your choice. You either write it as a log base 2 of 6 equals 5x, and then solve for x by dividing by 5, or you take the log of both sides, and then you have 5x log of 2 equals log of 6, and x equals log of 6 over 5 and log of 2. So either way, I'll just put it on my calculator because I already showed you how to do it before. So divided by 5. All right, so 0.51699, so we'll say 517. Okay. All right, now this last one, this is the worst, all right? So this one has exponents on both sides. So there's nothing to change, you can't move anything around, you're stuck doing this. You're stuck doing the log of both sides. So you're going to write the word log in front of this 4 to the 3x minus 1, and you write log in front of 3 to the 2 minus x. Well, now both of your exponents can come to the front. So you have, oh, go away. So you have 3x minus 1 times log of 4 equals 2 minus x times log of 3. So log of 4 and log of 3, these are just numbers. So log of 4 is 0.602. So you basically have this, 0.602 times 3x minus 1 equals log of 3 is 0.477. That is getting multiplied by 2 minus x. So now you just have this nasty problem where you have to, distribute and get some gross answers. So let's do it. So 0.602 times 3. So I have 1.806 x minus 0.602 equals, so 0.477 times 2, I said 0.954 minus 0.477 x. All right. So now I got to get the x's together. So 1.086x. I'm going to have to add the 0.477. So that's 1.563 x's. I'm going to take my 0.954 and add my 0.602. So 1.556, and then finally that is going to be divided by 1.563. Now 0.9955. There's a lot of error in this answer because of the rounding that I had to do to get these numbers here, but it's close. Okay.